talking about the zeros of a quadratic function. When we set a quadratic equal to 0, make sure yours says 0. I think there was a typo, and I think it said 9 for some reason. So when we set something equal to 0, make sure yours says 0, and solve, the answers we get are where the graph crosses the x-axis. Okay? These are referred to as the zeros of the graph. So the places where it crosses the x-axis are referred to the zeros of the graph because it's where the graph has a y value equal to 0. Okay, so for example, if I drew a function like so, and this is the point where it crossed, and that was -1, 0, and this is the point 1, 0. So the zeros are -1 and 1 because those are the points on the x-axis when the y value is 0. That's why they're called zeros. Okay? So we're supposed to sketch a quadratic function with zeros of -2 and 5. So here's -2, and here's 1, 2, 3, 4, 5, like so. Okay, and so it says sketch a quadratic. Well, a quadratic is a U. So anything that would go like this. Now, there are an infinite number of quadratics that would go through there. There's one that points up, there's one that points down, there's one that's longer and skinnier. So any one of those would be a quadratic function that has zeros of -2 and 5. You have to make a U shape, and you have to make it go through -2 and 5. Notice, every single one of these guys here has the same location. I didn't draw this very accurately. Okay, maybe I should draw them a little better, because right in between all of these would be the axis of symmetry. So the number right in between here, if I go 1, 2, 3.5 this way, 1, 2, 3.5, x equals 1.5 is the axis of symmetry that goes right down the middle. So you can see I didn't sketch this like the best because the U should be at the bottom right there. Okay, same thing with that blue. So if you want to make sure your graphs are nice and pretty, you could do that. It says use the zeros and the vertex of the quadratic to sketch a graph of the function. Okay, so I should be able to find the zeros because I can set this thing equal to 0 to figure out the zeros. Okay, so when will this thing equal 0? Well, it's already in its factored form, so it's equal to 0 when each of these factors equals 0. That's what we did yesterday. So when x is -2, this would become 0. Okay, if we add 3 here, add 3, when x is equal to 3, that's when it would become 0. So the zeros of this function are -2 and +3. So -2 is located right here, +3 is located right here. Those are the zeros. Now, it also wants you to know the vertex. So probably the easiest way for us to find the vertex, if you remember, is to type this into a Desmos screen to see where the vertex would be. So I'm going to type in the function that it asked for, which is xy equals parentheses x plus 2, close parentheses, and then parentheses x minus 3. All right. So where is that vertex? It's a half, -6.25. So I'm going to have to come on here and go to a half, -6.25. So there's a half, -1, 2, 3, 4, 5, 6.25. Be right down here. And then all I do, because remember, this is the guy that goes right down the middle. That's where he is. There's the vertex. And so now I can sketch a graph because it goes through those zeros and touches down at my vertex down there. Okay. Use the zeros and the vertex of the following quadratic to graph the function. Okay, so this one is not in factored form. So we can put this in factored form. Okay, how can we do that? Well, what multiplies to be x squared? That's x times x. What multiplies to be -2 but adds to be -1? What multiplies to be -2 but adds to be -1? That would be -2 times +1 is -2, and then that adds up to be -1. So when is this thing going to equal 0? When x minus 2 equals 0 and when x plus 1 equals 0. So that's when x is equal to 2 and when x is equal to -1. So 2 and -1 are my zeros. Let's see if I'm right. Let's see if I did this correctly. So I'm going to type the original function into Desmos to see how I did. So I'm going to type in y equals x squared minus x minus 2. Are the zeros 2 and negative 1? Yes, they are. Where's the vertex? A half, negative 2.25. So I'm going to put a half, negative 2.25. A half, negative 1, 2, 2.25 would be about right there. So that's the guy going down the middle. So when I draw my U, it's going to go through those zeros, through the vertex, and back up. Okay, so use the zeros and the vertex to graph it, and I have done that. I've used the zeros and the vertex to make a graph. Okay, so we're going to try this one more time. Use the zeros and the vertex to make the graph. So I'm going to put this in factored form. So what multiplies to be x squared? That would be x times x. What multiplies to be negative 12 multiplies to be negative 12, but adds to be negative 1. Well, that would be negative 4 times positive 3. That multiplies to be negative 12, but adds to be negative 1. So I'm going to set this equal to 0 to find the zeros. So you're going to set each factor equal to 0. So when x is equal to 4, I get 0. And when x is equal to negative 3, I get 0. So 1, 2, 3, 4. 1, 2, 3. So I've got my zeros. Let's see if I did this correctly by typing it into Desmos. Okay, so I'm going to have y equals x squared minus x minus 12. Okay, are my zeros 4 and negative 3? Yes, they are. Okay, and then I have a half, negative 12.25. Well, that's pretty far down there. So I'm going to count by 2's going down. So negative 2, so this is 1, 2, 3, 4, so forth, negative 1, negative 2. So I'm changing the scale. So I'm letting everyone know I changed the scale. So a half, negative 12.25 would be way down here. And then I go through my zeros, down to my vertex, and back up. Through my zeros, down to my vertex, and back up. Okay, if we know the zeros of a quadratic, we can work backwards to find the quadratic they came from. Okay, the graph of the quadratic crosses the x-axis at 5 and 2. So we know one 0 is 5 and the other 0 is 2. What is a possible equation for the quadratic function? Well, if x equals 5 is the 0, okay, then if we work backwards and say, well, where did that come from? Well, if you minus the 5 back over to the other side, that came from x minus 5. Okay, if I subtract the 2 back to the other side, this came from x minus 2, meaning 5 is what makes this 0, 2 is what makes this 0. So one possible function would be x minus 5 times x minus 2. Okay, that's in its factored form. I could also multiply it back together. X times x is x squared. X times minus 2 is minus 2x. Negative 5 times x is negative 5x. Negative 5 times negative 2 is positive 10. So I could also say this. So this equation and this equation would both have zeros of 5 and 2. Let's see if we're correct. One's in its factored form and the other one is multiplied back to be in its standard form. So let's see and double check that we're right. X minus 5, x minus 2. Okay, and then I have x squared minus 7x plus 10. Okay, notice, what do you notice about these two? They are equivalent. Now remember, there are an infinite number of quadratics that could go through here. For example, if I multiplied everything by negative 1, so that would give me negative x squared. A negative 1 times a negative 7 is a positive 7. And a negative 1 times a positive 10 is a negative 10. Notice if I multiplied everything by negative 1, it still goes through the same dots, but it's flipped over. Look what happens if I multiply everything by 2. Okay? You could actually multiply that 2 wherever you want. Look, I can put that 2 right up here at the top. Look what happens if I multiply that guy by 2. Does it still go through the same zeros? Yes. Is it the exact same function? No. Okay? So there's a lot of different answers we can come up with, but the two that I have over here, okay, do cross the graph at 5 and 2. So they have the correct zeros. Okay, let's try that one last time. A quadratic function has zeros of -1 and 4. What is a possible? Notice it says possible because there's a lot of answers with the given zero. So I'm working backwards. So -1 and 4 are the zeros. If I add the 1 back over, this came from x plus 1. If I subtract the 4 back over, this came from x minus 4. If I plug in -1 here, I get 0. If I plug in 4 here, I get 0. So one answer I can give is x plus 1 times x minus 4. That is a possible answer I could give, okay? Or I can multiply them back together, and that would be the same answer. Or I can multiply them by a number like 2, and that would still have the same answer. So let's just double check by typing it in. If I put x plus 1, f of x equals x plus 1, and x minus 4, does it cross at -1 and +4? Yes, it does. So that would be a possible equation.